Hi, I'm Miley. Welcome to my Fluid Mechanics series. This is my first video, and like a lot of courses, I'll be starting with hydrostatics. Everything is simpler before things start moving. This series is intended to be supplemental to in-class instruction, so I imagine I'll spend more videos on example problems than on high-level concepts. This first video covers concepts behind manometers. It's not meant to be too in-depth, I'm just hoping that it covers enough that you can confidently tackle the example problems I'll be posting next. Okay, let's get started. What is a manometer? Manometers are pressure measuring devices that use heights of fluid to measure pressure. They've been around for hundreds of years, and since the ideas behind them rely on basic hydrostatics, they're pretty easy to understand. There are a few different types, but the easiest to introduce is a U-tube manometer. In the manometer I've drawn here, both ends are open to the atmosphere, and I've filled it with a liquid. Let's say it's water. As you can imagine, at steady state, the fluid will rest like this, level, a straight horizontal line. But what happens if I pour some oil into one side? Try to guess what it'll look like at steady state. Okay, this is it. This is what the manometer looks like with oil poured into one end. If you can try this at home, I highly recommend it because even though the math checks out, it's not exactly intuitive. So what's going on here? At this point, I'm going to introduce two basic rules about manometers that you can employ in any problem to get the right answer. 1. Any 2 points at the same elevation in a continuous length of the same liquid will be at the same pressure. So the pressure at A equals the pressure at B because they're 2 points at the same elevation in a continuous length of the same liquid. But the pressure at C is not equal to the pressure at D because we're no longer in a continuous length of the same liquid. Okay. 2. Pressure increases as you go down. We've all experienced this while swimming to the bottom of a pool. So the pressure at C, PC, is less than the pressure at A, PA, and PD is less than PB. But what about PC and PD? We have to be really careful when trying to compare pressures that aren't in a continuous length of the same liquid, but see if you can guess this one. Okay, the pressure at C is going to be greater than the pressure at D. Why? Well, remember earlier I said both ends of the manometer were open to the atmosphere. That won't always be the case, by the way, but here, in this case, PD is at atmospheric pressure. PE, on the top surface of the oil, is also PATM. So PC will just be PE plus something. To find out what that is, we just return to basic hydrostatics, which tells us that pressure at a point is equal to pressure at a reference point plus the density of the fluid times gravity times the change in height. Remember, by the way, that this change counts as positive when we're going down. This expression can also be written, conveniently for manometer problems, as pressure equals pressure at a reference point plus specific weight of the fluid times the change in height. Specific weight, as you might guess from our first equation, is just density times gravity. So specific weight is to weight what density is to mass. Applying this to our U-tube manometer, we can say that PC equals PE plus the specific weight of oil times HC minus HA. Just looking at my terms, I can see that this is going to be a positive change, which matches my intuition from earlier. Good. We can also use this concept of specific weight to explain why the column of fluid on the left is taller than the column of fluid on the right. Since the specific weight of oil is less than the specific weight of water, you need more height to create the same change in pressure. We can write out an expression for PD in terms of the pressure at B, too. PD equals PB minus specific weight of water times HD minus HB. I always keep my height changes positive so I don't get confused by the signs. I know from hydrostatics and my manometer rules that the pressure at D is going to be less than the pressure at B, so I put a minus sign in front of the change in pressure. The same is true for finding an expression for PC in terms of PA. PC is less than PA, and I make sure that my equation reflects that. Note that I can replace PA with PB in that equation since PA equals PB. Okay, I think that's enough to get you started. U-tube manometers are pretty simple, but changing the geometry and adding lots of different fluids can complicate things. Some of these trickier problems will likely show up in your homework, so I'll go over some examples in the next few videos. Thanks for watching. See you next time.